Hey everyone, and welcome to this webinar. Today with us we have Brian. Hey Brian.
Hey.
Brian will be talking about C# in the browser using Blazor. I'm very much looking forward to this because Blazor is high up on my to-do list of things to check, but it's still on that to-do list. So very eager to see what you have to tell. Yeah. I'll let you introduce yourself in a bit, but before we start, I'll answer the most important question that people often ask, and that is, are we recording this webinar? And yes, we are. If you have any questions during the webinar, there's a chat that you can use. I'll keep monitoring the questions there, and if there's things that Brian might be able to answer, then we'll do some Q&A at the end. And with that, I'll hand it over and give Brian the stage.
Great. Well, thank you very much for joining me today. My name is Brian Jablonsky. About 10 years of kind of professional experience, mostly in the .NET world, been ASP.NET, and then obviously now with ASP.NET Core and Blazor. I'm a Microsoft MVP. And I'm the co-organizer of the New York City .NET User Group. So if you're ever in New York City after this kind of pandemic ends, definitely come out and join us. You can reach me on Twitter at Brian_Jablonsky. And you can check out my GitHub repository, github.com/bjablonsky. The slides and the demos will be there as well. So cool. So I'm going to be talking about Blazor today and kind of going through exactly getting started with Blazor, how Blazor works. There's two different kind of hosting models there, the Blazor Server side and then the Blazor WebAssembly. So I'm going to go into some depth there. We're going to look at kind of building your kind of first Blazor app. We're going to create a little to-do list to go through kind of doing a sample application. And we're going to talk about some kind of frequently asked questions that I usually get asked about Blazor. And then we're going to kind of open up for a Q&A. So cool, what is Blazor? So it's a .NET web framework that runs in a browser. It's basically lets you build interactive web user interfaces using C# instead of JavaScript. When you have to, for traditional, ASP.NET Core applications, you end up using some type of JavaScript framework, whether it be Angular or React or Vue, or if you just want to use plain JavaScript to do all of kind of your client-side interaction, you can very much end up doing that to kind of give that asynchronous kind of single-page application feel. Well, Blazor lets you do all that using C# and Razor instead of using JavaScript. There is some JavaScript that ends up getting used, but that's all kind of done for you in the background. You got to use some JavaScript interrupts. All of your code is basically going to be done in C# and Razor. So if you're used to doing that with Razor pages or MVC and with kind of traditional .NET framework, you're going to be very much have all the tool sets that you kind of need to be able to develop Blazor applications. So it uses kind of C# and HTML and Razor and CSS to kind of author these components. And web components kind of building block of a lot of what the web is today, with React and Angular. And so the name Blazor kind of came out of this nomenclature of the browser plus Razor, Blazor. So you might be saying, well, hey, why should I use Blazor? I'm using .NET Core, ASP.NET Core, I'm using Angular, I'm using React, and I'm kind of happy with what it is today. And that's fine. Personally, I'm not a biggest fan of JavaScript. There's a lot of kind of idiosyncrasies that I don't necessarily like about JavaScript. The other thing is I learned JavaScript a long time ago, and I'm not that comfortable with Angular. I'm not that much of an expert with Angular. I'm somewhat comfortable with Angular and learning it, and TypeScript is definitely nice. It's a big for me. It's a big improvement over JavaScript. If you're using React or something like that. But, you might be a .NET developer that maybe is just done kind of plain JavaScript using Bootstrap and jQuery or something like that. But, hey, how can you end up using Blazor to become your kind of single-page application? And so, why would you kind of pick Blazor? Let's say you're creating a new project. Why would you pick Blazor over, using React or using Angular or one of the other many JavaScript frameworks? Well, the thing is, you have all the .NET advantages. You have high performance. .NET Core, if you look at kind of the web performance benchmarks, it's .NET, ASP.NET has been huge. It's basically outpaced Node and JavaScript in every kind of way. And as far as kind of performance benchmarks, and with .NET 5 coming around the corner, which should be released next month on November 10th, they've even done more performance improvement, which is just absolutely insane. So you get that great high performance framework with .NET Core there. You also get the scalability, the maintainability, and the cross-platform that comes from .NET Core that everybody's been super excited about. The other great thing is you get to use Rider. You don't have to write JavaScript in kind of another code editor or whatever. You can do everything right from Rider using C# and .NET right from Rider. It's great. You don't have to context switch between two different languages and stuff like that. So it's really great. The other thing is you can kind of leverage existing .NET ecosystem for all the .NET libraries out there. You can go ahead, as long as they're kind of .NET Core compatible, you can very much use that for what you need to be able to build the applications for Blazor and to be able to run Blazor. So that's super exciting. So if you already have, let's say you have an older application that, you've been using some JavaScript and here and there, you kind of want to update a little bit. Well, Blazor might be a great candidate for that because, hey, you can, as long as it can build into .NET Core and, that migration path gets easier and easier and easier with a lot of packages supporting .NET Core. So, it's great to be able to say, okay, well, hey, I can just move everything over. If you have an MVC application or something like that, you have a lot of Razor. So a lot of things will kind of move over relatively seamlessly, I shouldn't say seamlessly, but easy compared to trying to have to rewrite everything into JavaScript and do everything like that. So the other great thing about this is you can share logic across the server and client. So, the logic, the Poker objects that you created with C#, you can end up reusing those from your server into your client, and so it makes reusability, and so you don't have to figure about, oh, I edited this on the server side, now on the client side I got to edit this, and so you end up reusing some of those logic components and classes that you've created. So that's another great thing that you can do. The other thing is you have two different kind of hosting models that you can do. You can do the server side hosting model, which basically it's kind of like your traditional server-side language where it gets rendered on a server, but there's some slight differences and some performance differences that have come out of Blazor that you'll see. It doesn't use HTTP, it uses something called Signal R, which is a WebSocket technology by Microsoft. And so that ends up helping kind of the client-server communication be super fast and really small. Or you can end up doing everything in the client-side UI. So you can actually run C# and .NET in your browser using something called WebAssembly. And so you basically, you're kind of disconnected from the server. You don't have to really go back to the server unless you're grabbing data from an API or something like that. So everything's kind of rendered and run on the server. So you can definitely do one of these two models. So, and we'll kind of discuss the advantages and disadvantages of going one with the other. So kind of great. You want to get started with Blazor? What do you need to have? Well, one is you need to have a WebAssembly compatible browser. That basically means any kind of modern browser, Chrome, Firefox, Safari, Microsoft Edge. If you're going to do Internet Explorer 7, probably not. But to be honest, Internet Explorer 7's, it's been deprecated and it's end of life. So you really shouldn't be using it anyway. You should be looking to upgrade to modern browsers. So you just need something that has a WebAssembly virtual machine built into it, and most modern browsers today have that. And you can go to this link, platform-status.mozilla.org/WebAssembly, and be able to kind of view what browsers are WebAssembly compatible. Next thing is you need .NET Core, because everyone's ASP.NET Core, so you need the SDK. I recommend getting 3.1 because it's the latest out there. It has long-term support, so that would be great. And you can end up, this also, .NET Core 3.1 also includes both the Blazor server side as well as the Blazor WebAssembly project templates. The other thing is download Rider 2020.2. They've included a lot of great updates for supporting Blazor and doing kind of WebAssembly and debugging, all that stuff. So you can basically end up upgrading to 2020.2 and being able to run it in Rider will be able to get you kind of building these Blazor applications. So I'm gonna, how does Blazor work exactly? It's kind of really simple. You basically have a component or multiple components or components of components. And then you have a Blazor hosting model. And that's basically kind of it. So what are components? So components are kind of, fundamental building blocks of web apps. This kind of web component architecture is being used in Angular and being used in React. And so it's also being used in Blazor because it's kind of a good practice and kind of understanding everything. And so components are basically kind of self-contained UI that kind of contains some HTML and some logic and some CSS to be able to kind of render UI components and be able to respond and to events like such as clicking or being able to inject data for when you call web API or something like that. One nice thing about components is that they can be nested, reused, and shared between projects. So, if you're creating a to-do list and you want to reuse that in a bunch of different projects, you can end up creating a Razor component called as a to-do component and then end up using it into different projects. So it's great to be able to share all that between all your projects. And lastly, everything's written in C# and Razor, HTML, and CSS. So no JavaScript needs to be run. If you're not comfortable with JavaScript, don't like JavaScript, haven't used TypeScript, that's okay. You should be comfortable with C# at least. I would assume if you're a .NET developer, it might be F#, but this is kind of C# and Razor. Razor's been around for a long time. If you've done any kind of MVC in the .NET framework with .NET Core, there's also MVC and Razor pages. So you should be relatively comfortable with the Razor syntax as well. So then we build these components, and then we gotta somehow host them and have all the kind of glue and the framework underneath to be able to kind of host these components, render everything that needs to do, and do all the logic. There's two different hosting models. There's one called Blazor Server, which the server is responsible for rendering the UI and then communicating back to the web front ends to be able to do all kinds of the DOM updates. Then there's this other hosting model called WebAssembly. And WebAssembly runs all in your browser, actually runs a version of the .NET framework in your browser, and it's responsible for doing all kinds of what your server would traditionally do in Blazor Server of rendering the UI. That's what's being done on your client side in your browser with the Blazor WebAssembly. So, that's great if you want to be able to, certain situations you might want to use Blazor WebAssembly versus Blazor Server. If you're having a huge if you're Black Friday e-commerce, you might want to use WebAssembly because you offload a lot of the rendering from the server. Now we'll talk about a little about performance with the Blazor Server. It's you saying, okay, hey, I'm rendering the UI on the server. That's going to take a lot of resources, and I'm going to have to scale out hugely. We'll actually kind of look at that. And, Microsoft actually provide a great little resource about talking about scalability with Blazor Server. We'll look at that a little bit later, but we're going to actually talk about Blazor Server first. So, Blazor Server is basically decoupling the component rendering logic in the browser and shipping that over to the server, and then basically using some type of service to talk back and forth between the client and the server, and then letting the client go ahead and be doing the re-rendering. So the Blazor components will get actually hosted on the server, and then it handles these user interface updates via something called SignalR, which is Microsoft's WebSocket framework. And this was basically released as general availability in .NET Core 3.0. That was back in November of 2019, if you can remember as far back as 2019, and it seems like ages ago. But so yeah, it's been production ready to rock and roll. There's actually I've been talking to some people. People have actually been using Blazor Server in production instances, so it's not just something that's brand new and nobody's using it. Nobody really knows. There's actually a lot of people starting to use it because, hey, for kind of intranet sites or something that doesn't have kind of Black Friday scaling out huge amounts of users, that you can end up using Blazor Server just fine. So, kind of traditional server-side rendering, you have your browser, you have your UI, you have some type of web worker that's responsible for kind of manipulating the DOM using JavaScript and handling API requests and data requests. And it basically, traditionally uses HTTP with your normal HTTP RESTful services, goes over to the server, talks to ASP.NET Core. It will end up rendering stuff, talking to the web page, then going ahead and taking all the inputs, rendering out the UI, and dumping it back via HTTP as HTML to the browser, and then it ends up going ahead and rendering it out. So Blazor is slightly different. It's very similar as far as what's using for server-side rendering, but it's kind of two different things. One is that inside of your ASP.NET Core application, you have this Blazor component framework that ends up rendering out these Blazor components, and it ends up using this signal R to be able to transport things back and forth. And so you'll see that when you're looking at kind of using Chrome to maybe do your inspection of your network, you can see that there's no network calls being made. And what's actually happening is there's WebSocket that gets opened up via signal R, and all the kind of communication gets done there. So cool. Let's actually build and run a Blazor Server application real quick. So here we are. We got JetBrains Rider open, and we were, for sake of time, I already have a solution that is the JetBrains. That is the Blazor Server. As you can see, as everything kind of opens up, this kind of will look very similar if you've done Razor pages or kind of not necessarily MVC, but somewhat similar to MVC. Everything with ASP.NET Core. You have your program.cs, which is it's a console application that's responsible for firing off your web browser and starting everything up. You have your startup.cs file, which has everything that you need to configure. There's some certain different things, such as we're using the server-side Blazor service and using the Map Blazor hub for doing our routing and using with our endpoint. But for the most part, it's relatively the same. You have this app.razor, which is responsible for your routing. If you want to be able to do any kind of weird and funky things with that, you can definitely do that. Your imports is basically just showing you all of your shared imports that you need to use. So you don't have to reuse this over and over and over to retype all this stuff in your actual Razor pages. And so in your actual Razor pages, these are actually Razor components and Razor pages. So you can see this is responding to the root directory route, and then it kind of goes ahead and renders out some HTML. Let's look at the kind of counter here. Here's a simple counter that's responsible for when you click a button and increments it. So let's actually build the solution, and let's actually run and debug it. So here we go. This is a Blazor Server. So this is kind of the template that you get out of the box. And as you can see, you can kind of click here. Oop, we actually have a breakpoint set. Get to that in 1 second. You can click here and see that, as you click, the counter increment. So let's actually kind of look at the dev tools and kind of see what everything kind of looks like. So let's clear everything. We'll disable the cache. We'll make sure we have everything. We'll do a empty cache and a hard reload here. So you can see it's, relatively small. There's here's your site. Here's some JavaScript. It's not too much. You can see this WebSocket that's being created. But now let's click the counter. And what you'll see is that you're noticing there's nothing really being done here. There's no HTTP request or anything like that. It's actually all being done by this WebSocket. So if you actually look at here in this WebSocket, you can see we'll actually clear it all, and then you can see when I click it, you see a whole bunch of data gets sent back. You can actually kind of look at that. These are all kind of binary compressed format. It's not really meant to be able to be seen and debugged by a developer, but this is just what's communicating back and forth with the server. What's one nice thing about this is, let's say you wanted to debug this. Well, you can definitely set a breakpoint in your Rider application. So we're in, the counter.razor. We have, whenever this fires off, it's going to increment count. We're going to do count ++. So let's go back to our web browser and click me. And you notice it now breaks. You can see Rider flashing up down here. You can see right here, here's where everything's being evaluated. So current count is 5. We're going to go ahead and add 1 to that. And we can go ahead and resume, and you can go back to the Blazor. You can see they end up to current count 6. So if you want to do any kind of debugging or anything like that, it's very similar to how traditionally done with MVC and Razor pages. So you can end up, it's very, very similar, just slightly different technologies of how things are going to work in the back end. It's a lot faster and it's lightweight. So yeah, let's get back to the slides. So now that we've shown you kind of what Blazor Server looks like, let's look at the other hosting model called Blazor WebAssembly. So this WebAssembly is responsible for hosting the Blazor components in the browser using a WebAssembly-based .NET runtime. And this is kind of a true single-page application. There is no, you only need to talk to the server when you do your first kind of, get of the index page to be able to get all the assets that you need to be able to run. But after that, all you need the server is if you're trying to get any kind of data or doing any kind of server-side logic, accessing databases or stuff like that, or APIs. Technically, you can run this as just straight HTML page. There's these things called static site pages out there. Blazor WebAssembly can be run on a static site page. There needs to not really be a kind of back end here to be able to host it. So you can end up pushing this content out to a CDN and using Azure static sites to be able to run all of this. And you can basically run a website for pennies on the dollar a month. And what's great about it is it can scale out super quick and super fast. You don't really need to do that. All you care about is serving up the data and kind of you have your Azure content delivery networks and endpoints to be able to do all that. But it's kind of beyond the scope of this talk, but it just something to note that as you're kind of trying to decide between, do I build a Blazor server or do I build a Blazor WebAssembly? If you don't necessarily need a lot of back-end logic, maybe you just need some Azure functions or an API that you call on or something like that, you might want to look at Blazor WebAssembly. So great thing about Blazor WebAssembly is it utilizes your client resources. So for doing the rendering, for doing the logic, it's all done on the browser. So you don't have to have a super powerful server. You can actually, again, either do kind of the serverless model, or you can have just a kind of standard, Nginx type web server that's serving up a whole bunch of static files and then kind of responding to maybe having a ASP.NET Core web API to be able to respond to it. So nice thing about this is it also supports offline support. So one thing with the Blazor server is you got to have that connection to the server. As soon as you don't have a connection with the server, you will see that it ends up breaking. And we can actually kind of real quick kind of hop over here. If I go ahead and stop debugging, you will see this now freezes up the browser and says attempting to reconnect the server because it kind of lost that WebSocket signal R connection back to the server. So with Blazor WebAssembly, this doesn't happen. Everything's kind of done in the front end and on the browser. But just to be kind of cognizant about that as you're kind of deciding what hosting model you want to do. Again, it supports static sites and it supports progressive web applications. So that's cool if you want to be able to do progressive web applications where you kind of install it as a native component, either in in the mobile side of things or in kind of desktop. You can end up using progressive web apps to kind of have that somewhat look and feel of a native app without being having to open up a browser. So that's kind of cool. The other thing is you need to have .NET Core 3.1.300. Not just 3.1, but you have to have at least 3.1.300. And that's because Blazor WebAssembly was actually pushed back a little bit before the launch of .NET Core 3.0. It was actually launched in May of this year, with Blazor WebAssembly being kind of the being generally available. So a little caveat there: if you have .NET Core 3.0 and you're trying to run Blazor WebAssembly, like where is it? It's not there. Make sure you just upgrade to 3.1.300, and you'll end up having that template there. So cool. You might want to say, okay, well, I understand how traditional web servers work with server-side rendering, but how does Blazor WebAssembly really work with this whole client-side rendering, running a .NET framework in the web browser? How does all that work? So, kind of traditional client-side rendering, you have the browser, you have some type of UI thread that's responsible for kind of managing, updating the DOM and talking to something like a service or your web app or, all of your logic in your code, and kind of Blazor sits inside of there. So quick little side note of you got to understand a little bit about WebAssembly before to give you kind of better overview of how Blazor WebAssembly works. And so I'm going to give you kind of a quick crash course. This is kind of 10,000 foot view. You can definitely get into the nitty-gritty details of WebAssembly. I'm not going to do that. I don't necessarily know all the details about WebAssembly. So if you're definitely interested, take a look at it. It's really cool technology. You're able to transpile stuff from C, C++, Rust, Python, whatever you want to be able to do. You can actually transpile that over to WebAssembly and run it in the browser. So WebAssembly is basically kind of a binary instruction format for stack-based virtual machines. There's currently a stack-based virtual machine in every web browser called the JavaScript virtual machine. WebAssembly was basically meant to kind of augment that. So it's a kind of new type of code that's meant to be run in the web browser. And the reason why it was created was because there was kind of performance problems with JavaScript. Some things, very mathematical, heavy algorithms are kind of slow in JavaScript. So, I mean, JavaScript is great for doing your DOM manipulation and updating your DOM tree and all that, but doing some kind of heavy, intensive mathematics work, sometimes JavaScript isn't the best at. So they said, hey, how about we just create this new, stack-based virtual machine, kind of augment the performance of JavaScript. And so you actually will run both, or a web browser can run both. So WebAssembly is not here to replace JavaScript, and there's actually a good reason, because right now WebAssembly doesn't actually support updating the DOM. It actually has to talk to JavaScript to be able to update the DOM. So maybe in the future they might end up adding that functionality, but as of right now, WebAssembly is just basically another place to kind of run some application code. So the kind of goals of WebAssembly was, be fast, efficient, and portable. The WASM code is meant to be executed at kind of near native speed in the browser. So if you kind of look at when you transpile from like a C or C++ program to WASM, it should be almost near native of what traditionally a C or C++ runtime on your desktop would look like. So that's something that they're definitely were focusing on, because again, there's that JavaScript performance that they were trying to address. It's also meant to be readable and debuggable. To a sense, it's human readable, but I would not recommend trying to program WebAssembly by hand. It's a low-level assembly language, but most people are going to use some other type of high-level language. C#, C, C++, Java, Python, whatever you want to use, and then kind of transpile it into WebAssembly. But it is technically readable and debuggable. But again, I would not try to write this by hand. Sure, if you want to write it by hand as an exercise, great. But if you're doing kind of production stuff, please, don't. You're not writing using C# as your day-to-day backend test. You're not writing Intel assembly underneath the hood. So. The other thing is it's very much like JavaScript in a sense that it's supposed to be secure, in the sense that it runs in a safe sandbox execution environment. So you don't really have to worry about, well, okay, I can run native code, I can run C and C++. So what about pointers and memory leaks and all this stuff, and being able to maybe break out of the browser and actually access something on the desktop and the operating system? Well, no, it's kind of all sandbox and it's safe. So you don't really have to worry about that. Sure, you can crash that virtual machine, the WebAssembly virtual machine if you need to, if you're doing some weird stuff with, C and C++, with the kind of how you're doing with memory management, stuff like that. But you're not able to kind of get outside of that. I'm sure there could be some bugs here and there, but that's not meant to be, it's not designed as a feature out of the box. So basically, the WebAssembly kind of consists of two parts. There's the virtual machine that, is part of the browser that runs the code. And there's a set of APIs that kind of control the browser. And, it uses JavaScript to be able to go ahead and talk to the DOM and do any kind of DOM manipulations that needs to do, or it can respond to events. So when you click on a button, there's a JavaScript interop library that ends up capturing that user event and pushing over to WebAssembly to be able to say, hey, this is the component that got clicked. Here's some state about it. Go ahead and do all of your logic. And so, it's just basically meant there to kind of create additional virtual machine that you can run other types of program languages, and you can augment JavaScript. So it's not meant to replace it; it's meant to augment it. And that's kind of where kind of Blazor is too. It's just another option out there. Blazor's not out there to kind of take over JavaScript. Just to say, hey, there's another option. If you want to do JavaScript, if you have MVC or Razor Pages applications, this might be a great kind of alternative instead of having to rewrite everything. So, so let's look at what ends up happening. So you can take your C or C++ or C# source code, you end up using this transpiler to compile it down into WASM, which is WebAssembly. And then this WASM module is loaded, and then you basically will load everything up in HTML and then use some JavaScript glue to be able to load up this WASM and to be able to communicate and register some APIs to be able to do some communication with that WASM. So now, great. How does actually Blazor WebAssembly work? So you basically have some C# and Blazor code files that are compiled into .NET WebAssemblies. Those assemblies in the .NET runtime are downloaded on the browser. The browser uses JavaScript to bootstrap some of the .NET runtime and load all the required assemblies, and then uses the JavaScript for doing DOM manipulation and calling to and from. So kind of looking into it. So if we take a Blazor WebAssembly application and go ahead and compile it, we end up getting kind of, this is the output from the bin debug folder. So you can see that there's a Blazor WebAssembly.dll, there's some root properties and stuff like that. So you can see everything kind of compiles down to a DLL .NET WebAssembly, just like you used to with MVC or Razor. So then kind of digging in a little bit deeper, you have, when you look at into the actual www root, you can see that they end up giving you kind of this Blazor WebAssembly.js, which is kind of what's being called by the index.html page. And we'll look at that here in a second when you look at an example of the Blazor WebAssembly. That it ends up kind of bootstrapping and loading up everything that needs to load, and then it ends up loading up this .NET.wasm file. And that's kind of the .NET framework that runs in WASM. So it's, it's true and interpreted, running your IL framework to be able to interpret from your DLLs into the WebAssembly. So it's kind of another layer of abstraction. There is some performance issues there. The Microsoft team is working, and the Blazor team is working great with being able to fix some of those performance issues, because there were some real bad performance issues when the kind of it originally got released, and some of the original release candidates, that there was some slowness with kind of, if you were rendering a lot of components on the DOM and stuff like that, that was occasionally a little slow. With .NET 5, they're doing some really huge performance increases with that. And then we'll talk a little bit about later about, there's a possibility about something called ahead of time compilation that can actually compile everything down into WASM and run everything as WASM. So you don't have this, .NET framework that's running on top of WASM, then you have your code running on top of that. So you kind of have less levels of abstraction and that, so it kind of runs a little bit more better in performance. So here's the HTML page. So as you can see, there's not much really here. There is, this kind of looks very much like an Angular or a React kind of page, where you have your, your JavaScript references, you have your CSS references, and then basically it's just kind of a stub page to be able to load everything out. And you can see down here, you have your kind of just div tag where everything's supposed to be loaded. And then, your app tag where everything's supposed to be loaded, and then you have kind of an error tag if you don't have a JavaScript supported framework or something like that, or a JavaScript supported browser. And then you have this kind of one single script, that's that blazor.webassembly.js. That's, again, responsible for kind of bootstrapping and loading up the .NET runtime and kind of doing all the connection that you need to do. So if you kind of look at what the .NET runtime looks like, and kind of the Chrome browser dev tools, you can see, okay, we hit the local host, we load everything up, and then this line right here, this red line right here, is basically done. That's index loaded everything up. That's all of the stuff that ended up loaded up from the actual index. From there, the Blazor.webassembly.javascript actually will load up this mono.javascript, which actually is now called .NET.webassembly or the .NET.3.2.0.js. But it was based on the mono framework. And so that JavaScript is basically is responsible for loading up the mono runtime and loading up the rest of your client. So, the mono JavaScript ends up loading up the mono WebAssembly virtual machine, and then it's ended up responsible for loading up all the rest of your DLLs that you would use, like you would traditionally use with a web framework. And then kind of looking at how the DOM manipulation works, because it's always a question. Well, okay, you're running .NET in a browser. How does everything kind of look? So basically, it's relatively simple. You have this Blazor JavaScript interop. This is your Blazor.javascript blazor.webassembly.js file that's responsible for kind of doing your interrupting. So you can see that, when the C# code runs, it passes everything over to the interrupt, and then it can pass over changes to the DOM. Now, if there's any kind of changes to the DOM, it ends up creating an event trigger in JavaScript, which passes it back over to C#. C# processes that event, creates a UI difference, so it doesn't update the entire DOM. It basically just says, okay, here's the DOM that I need to update. This is the changes that needs to get updated. Passes that through to the JavaScript, the Blazor JavaScript framework, and that's responsible for going ahead and update. So it doesn't do like a full page refresh. If you're looking at like old Angular JS, some of that was was an issue of having to completely re-render some of your DOM. This just does incremental updates, so you can see it's kind of very fast in the sense it says only give me the UI differences. So, well, cool. Let's actually kind of open up our WebAssembly project and kind of look at how it all works. So we will actually close this. We'll go back to our writer. We will close our server, and we'll open up our Blazor WebAssembly. And all of these projects I'm showing you, they were just file new. These were just basically what's provided for you out of the box. I just didn't want to go through file new. We will do kind of file new when we're kind of building out an example web application. But just for time's sake, I want to run over. So we're going to go ahead and build everything. And then we are going to run it. And so here, great. Let's now look at the network. Let's do a cache and refresh. So now you can see here we go. We have the .NET, the Blazor WebAssembly JavaScript, which is responsible for running the .NET, and .NET.js is responsible for looking up all that WebAssembly stuff. And so now you can see there's no WebSocket here from Signal R. So if you go ahead and click all this, you won't see any kind of updates or anything here. If you want to actually look at and kind of now, the only caveat here is that you can't really debug this right now, at least in kind of Visual Studio or Rider, of being able to debug a web front end here. So if you're doing the WebAssembly side, you can't actually set breakpoints on the server side and map everything over quite yet. It's coming, but how you actually might be able to do that, if you want to actually see the code that's getting executed inside of DevTools, what you can do is you can actually fire up the Chrome web debugging. So let me copy and paste this. This is basically running the Chrome application, adding the remote debugging port, and well, that was working. Fire up. Well, that's the funs of doing a live demo. Let me see if I can fix that. We'll get back to that a little bit later. I'll show you kind of how we end up showing some of the debugging in the Blazor WebAssembly. I will look into that when we're answering some questions. I'll kind of show a demo a little bit later, but just to kind of get through some things. So, all right, jump back to the slides. So, okay, you've seen both kind of the WebAssembly and the server side of things. What are the trade-offs? Why should I choose one over the other? So Blazor WebAssembly has a larger download size. You're downloading a WebAssembly, you're downloading the .NET framework, you're downloading DLLs, so you're going to have this larger download size. Whereas Blazor Server, you have a very much smaller download size. It's basically just creating a smaller web worker and opening up a WebSocket to be able to talk to the server. So things are going to load a lot faster, and it's going to be able to be a smaller download size. Again, with Blazor WebAssembly has a bit of a slower load time because you're trying to end up loading an entire framework in your web browser. So there's that bit of load time where it takes a little bit to be able to bootstrap everything and get everything up and running. So that's something to consider if you want something super fast. With Blazor WebAssembly, the code is run on the client. Unfortunately, I didn't get to show you, but hopefully a little bit later on, I'll be able to show you that you can actually see all the actual C# code. So if you're trying to hide some things and you don't want to be able to expose some of this code, you might not want to use Blazor WebAssembly. You might want to use it all in Blazor Server. Now, obviously, this is the same type of thing with, single page applications with JavaScript, Angular. Obviously, you just, if you need to use server-side logic or authentication or do anything like that, end up using, calling out to an API and doing everything there. You don't actually do any kind of your sensitive information inside the browser. Offload that to onto the server. So, the one thing is that Blazor WebAssembly also runs a stripped down version of Mono. So it doesn't support everything you might need. So things like necessarily, let's say you're trying to create a Word document or something like that. Well, you're not going to be able to call out to create a Word document and do all that stuff. It's kind of a stripped down version of Mono if you're trying to maybe talk to some IoT devices or do some, something else, maybe talking to a printer, doing something like that. You won't really be able to do that in the Mono framework that runs in the browser. Whereas Blazor Server, you have the full .NET Core runtime. So if you want to fire off and do some other things, talking to IoT devices, doing whatever, you can end up doing that. Blazor WebAssembly, it's lower latency. Everything kind of runs on the browser, so everything is instantaneous. The only kind of server back and forth communication you have is if you're trying to get data or talking to an API. So it's super low latency. It's basically as fast as the browser can render it. Or Blazor Server, on the other hand, there is a bit of latency there. Now, there isn't much, but there is some latency. Using WebSockets to be able to communicate back and forth with the server, and you got to wait for the server to render things and bring it back. So if the server is super loaded, you might see a little bit of more latency. Or if you're over a super slow connection, something that has high latency, maybe you're on like a cell phone and you're out in a remote place where you don't get 5G service, you only get 3G service where things might be a little bit slow. You might see a little bit of a disconnect with when you click something for it to be able to get the data back and to render it and do everything like that. So that's something to definitely think about. Blazor WebAssembly supports, like I said, offline support. It supports progressive web applications. Whereas Blazor Server, if you go offline, it breaks the application. And you saw earlier when I stopped the Blazor Server that it wasn't exactly working. It says that it's offline, attempting to reconnect. So if you need to support offline functionality, you might want to look at Blazor WebAssembly rather than Blazor Server. So the Blazor WebAssembly consumes fewer server resources. It's basically just serving up some static files. All the kind of logic gets run onto the client, and the only thing the server is responsible for is dealing with data requests and stuff like that. Blazor Server is responsible for rendering the UI. So obviously, there's going to be consuming more server resources on Blazor Server. So you definitely got to, be aware of that if you're doing a Black Friday e-commerce website where you're going to be scaling out to, millions of requests per second. You might want to be able to look into that where, okay, maybe your Blazor Server model might get bogged down. But we'll look at it in just a second. Blazor Server is pretty performant as is. So, I don't be afraid about that. If you have certain scenarios where, yes, you're getting millions of clicks per second, sure, that's something to be concerned about. But to be honest with you, most people, they're not getting millions per clicks per second. And what Blazor Server can offer you will definitely be able to handle it. Maybe you have to scale out just a little bit to be able to handle your workload, but it's not something that you're going to see and you see it buckle and come down to its knees, again, unless you're running something super crazy. So, I mean, if you're the Walmarts of the world or something like that, sure, maybe. But the other thing is WebAssembly requires a WebAssembly compatible browser. If you're, you got to have WebAssembly. Now, most modern browsers support WebAssembly, so that shouldn't be an issue, but you might need to support maybe some older browsers or, a certain internet browser that is no longer supported by Microsoft. And so be cognizant of that. Blazor Server, again, can go ahead and load everything up it needs to be able to do, and all the UI is kind of rendered on the server, so you can actually support some of these older browsers that don't necessarily support WebAssembly. So, kind of some of the frequently asked questions I usually get is, does Blazor WebAssembly compile my entire .NET assembly into WebAssembly? No, it doesn't. It basically runs a version of the .NET framework that is compiled into WebAssembly. It's actually done, it ships to you as a WebAssembly module. You don't actually compile that. And then you just run everything on top of that. So you don't actually compile anything technically into WebAssembly. Now, caveat here is there might be some future static ahead of time compilation that they're kind of working on. We were hoping to have this done by the Blazor launch 3.2 back in May. There's a lot of underlying work that has to be done with the modern time framework to be able to compile it into WebAssembly, and that's not part of kind of Blazor's wheelhouse. That's not part of their project to be able to do that, and so they're kind of dependent on somebody else to do that. And so we were hoping with .NET 5 to have that. And unfortunately, with .NET 5, it's they weren't able to get everything done that they needed to. So they're pushing it back to .NET 6, which should be released November of next year. So fingers crossed that hopefully that'll be there. But, what a lot of people were complaining about was that sometimes Blazor WebAssembly was a little slow with some things. Actually, Blazor with .NET 5, Blazor's actually done a lot of performance improvements. So some of your concerns about how slow Blazor WebAssembly might be will be taken care of in kind of .NET 5. There's a lot of great performance improvements. So yes, technically doesn't, you won't be able to run a full WebAssembly version of your code, but, for all intents and purposes, the Blazor WebAssembly is pretty good as is. So the other question is, okay, well, you're downloading a .NET runtime. Isn't that kind of big? I download the .NET runtimes. That's like 30 megs or something like that when I have to download it from Microsoft. Is every time somebody going to hit the Blazor WebAssembly app, they're going to have to download 30 megs worth of a runtime? Actually, no. So it won't be really that big. I mean, it's big-ish in the sense of a web app, but if you look at some other websites out there that are running, Angular and React and Vue and some of these other websites that have huge JavaScript frameworks, all kinds of dependencies and stuff like that, they actually kind of get into the couple megs, 10 maybe 15 meg range of all the assets that you got to download. So the .NET WASM runtime is 1.8 megs. It's about 800K compressed. gzips and compressed. The MS Core Lib is about 4.1 megs. You compress down to about 4.1 megs uncompressed, and compresses down to about 1.4 megs. So, I mean, overall, it really depends. They kind of do a little bit of tree shaking there to be able to say, okay, we don't need these certain features of the .NET runtime, so don't include all these other DLLs that we don't necessarily need. Only include the DLLs that we actually need to be able to run your application. So the other great thing about this is you can serve these files up from a content delivery network, much like you kind of do with maybe Angular or Bootstrap or React. You basically have a CDN out there that's responsible for downloading all this. And so once they have this specific version of it, they don't have to go out there and download again. So it's kind of a one-time download. And then if they have that cached in their browser, they can end up reusing that. So now every time you end up restarting, you don't have to download this huge file. So that's something to actually consider. Yes, you kind of, the first run of performance might hurt a little bit, but subsequent runs, you're not going to really have that. So something to be cognizant about. So the other question is, well, great. Can I use Blazor without a .NET backend? Yes and no. So with Blazor WebAssembly, you can actually use it with any backends. If you want to use Python or JavaScript or Java or whatever great server-side language you want to use, yeah, you can definitely use it with that. Again, this is just, it basically is loading up a JavaScript that's responsible for doing some bootstrapping, and that's basically it. And kind of Blazor WebAssembly takes over for the UI from there. Then after that, it's all just kind of API requests. And so you can definitely use any type of backend, or if you want to go serverless, you can use something like Azure Static Web Apps to be able to serve up your Blazor WebAssembly without actually having a some type of backend. You can use Azure Functions to be able to respond to any kind of request that you want to do or kind of anything like that. So you can definitely do that. Now with Blazor Server, unfortunately, it does require ASP.NET Core because again, it's all being run on a server, and all of your server side, all your client side client rendering, UI rendering is being done on the server side. So yes, Blazor Server does require ASP.NET Core. It does not run on a .NET framework. Blazor Server is only targeted for .NET Core. So Blazor Server will not run in .NET framework. So I was kind of alluding to this before. So what about, we were saying, okay, well, there's all kinds of this server-side rendering that's happening with the Blazor Server. Isn't that kind of going to be a little bit cumbersome to the server, and I'm going to have to scale out? Well, Microsoft actually did this really cool dev blog where they kind of done a load test on Blazor Server, and they basically took a VM with one CPU and 3.5 gigs of RAM, and they handled over 5,000 concurrent users. So they noticed that the main bottleneck is the server's memory. So you don't necessarily need a very CPU-hungry server. You can actually get something that's maybe a couple of cores on your CPU and something that has a lot of memory that is able to kind of handle all the connections and everything you're able to do. And then you can end up using the Azure Signal service to quickly and easily scale this out rather than kind of running things behind the scenes. So that's a great little feature if you want to be able to use it. You can definitely go to this link. It's included in the kind of slides at the end, kind of show it. But yeah, you can end up kind of looking at it and understanding. So cool. Real quick, it's about, we got 10 minutes, 5 to 10 minutes left. We'll build a quick little Blazor web app. It's a little to-do list and just trying to let you run through everything and kind of show you how you end up building everything. Let's see. So let's close the solution. Terminate. We'll say open up a new solution. And we will go to here. And we will call this Blazor to-do app. And I have 5.0 installed, but let's go back to 3.1. And oops, let's pick this. And we call this Blazor to-do app. And you can see in here, so you select it under the .NET Core templates. You can see ASP.NET Core web application, and then you can see under the type, you can see all kinds of, you can actually do your regular web APIs and stuff, but actually up here at the top, we have the two options for Blazor Server or Blazor WebAssembly. I'm going to choose Blazor Server app just because, I want to. So we're going to, if you want to be able to add authentication, you can definitely do that. We're just creating this quick, easy to do app. Not going to really worry about that. So cool. We'll hit create. And we'll let Blazor run its magic behind the scenes, loading everything up, building everything, syncing everything. Give it a couple seconds. See, processing, loading. All right, cool. So let's build this real quick. And it's built. So now let's actually run. Make sure everything runs. And yes, we got everything running. Everything kind of works. Yep. Okay, cool. So now let's stop debugging. Now let's create a to-do list. So, kind of going through here, you have your shared pages. And this is kind of, if you're similar with the Razor Pages or MVC, you understand about having your kind of main layout and your nav bar and all the stuff like that. So these kind of the shared components that end up being reused in all the other pages. So under the shared components, we have a nav menu. We'll definitely want to create a link to that because this is what's responsible for, actually, if you look up here, this is your nav menu over here, your home, your counter, your fetch data. So if you go here, you can see this is your home, your counter, and your fetch data. So let's add a new link. And for the sake of time, I have some code I can copy and paste. So again, just creating, a list item, adding some bootstrap, creating a nav link, and then creating a to-do list. We're going to go ahead and point to the to-do. So we're going to go ahead and save that. And let's run it real quick. And we now have our to-do list. But if we click to do, You see, yep, there's nothing here at this address. Now we got to end up handling when we go to /to-do to actually have this show up. So under pages, so again, this is part of if you kind of end up looking at your startup.cs, going down here to this map Blazor hub. This is kind of very similar to Razor Pages and how it works. So there's if you see on each Razor component, if we open it up, you can see that there's this @page directive, and basically we'll go ahead and map where it's going. So you can see the index at Razor is mapping to the root. If you look at the fetch data.razor, it's going to the /fetch data. So let's go ahead and create a new Blazor component. So we're going to right click on the pages, say add Blazor component. We're going to actually do a page, and we're going to say to do Razor. And then go, Writer has these awesome features to say, hey, do you want to add this file that you created to the Git? Yep, definitely do. So as you can see, by going ahead and go ahead and make that lowercase, Writer out of the box goes ahead and creates some kind of templating for you, gives you your code block, gives you kind of your page directive, and goes ahead and routes you to where you're supposed to go. You can change this if you want to, but out of the box, to do is fine. And then it gives you kind of some stub code. So again, in the sense of time, I am not going to type this all up. I am going to copy all of this, and we're going to paste it. What was that? Page. All right, so let's kind of look at this real quickly. This is basically a to-do list. I have an H3 to-do list. We have a for each that basically goes through in all the to-dos and goes through and basically says, is this done? Is this a title? And so on. So, I don't think yeah. So we have that. And so if you kind of look at the actual code, you can see that here is we're basically creating a to-do item with the to-dos, creating a new to-do. And then we have this kind of add to-do, which is responsible, that gets called right here. This method gets called on this button, on click, add to-do. We end up calling this function, which basically looks at it, says, hey, is this new to-do that's getting, it's basically being bound. So you can see this @bind here, this new to-do is actually getting bound to the string right here. So when you input a text box, we type something in that gets end up binding. And so the value gets end up passing into this string member here, data fields. And then you can see the button ends up binding to the on click method gets bound to this add to do. And we do some checking to see, make sure it's not null or it has white space. And if so, basically add it to this list and add the to-do item and go ahead and update the to-do string to empty. So everything works. Now, that's great and all, but you notice we don't have a to-do item. This is something that's not here yet. So going up to the data, now obviously you can end up creating, doing great server architecture of creating common class libraries and all that. Again, this is just a sample application. This is not going to be the best, best practices here, but we can go ahead up to a data, and this is kind of where the weather forecast and the weather forecast service is, but we're going to go ahead and say add class interface, and we're going to call this to-do item. Yes. Again, we'll go ahead and add that. And so what we'll do in the sense of time, we will go ahead and copy and paste some of this. This is a very simple object class. There's a string, and then there is done. So we got that, but now problem is we got to go ahead and link this to here using. Otherwise, it has no idea where that to-do item is. So we're saying, okay, we'll go ahead and use this Blazor to-do app.data, which is where our namespace here. So we'll be able to pull that in so we can use that, and everything should be good to go. So fingers crossed, we'll go ahead and stop the debugger, go ahead and build our solution. Fingers crossed that everything builds correctly. Okay, builds. So now let's debug it. And there we go. So we're fired up a Blazor Server up, and now you can see we have our to-do. So let's click on our to-do, and great, we got our to-do Razor page. So let's type in add more features to list. Add that to the to-do. Demo to-do list. Okay, we just demoed that. So let's check that we did that. And so you can go ahead and see how everything kind of works. If you want to go ahead and debug it, again, you can kind of go through here and click on the, add breakpoints, go back to your thing, go back to web application, another to-do, add to-do, and then you can see it ends up going into your breakpoint. You can go ahead and debug it and do all that stuff. So great. Let me try. I just saw in the comments. Let me see if I can't fire up the Google Chrome, because I was using PowerShell. There we go. And so thank you, Martin. Appreciate that. A little tip. So this is, let's go back. We're going to close this Blazor app. So we're going to close the solution, terminate it. We can go back to our WebAssembly real quick. We're going to build the solution. And we're going to run it. So we're actually going to copy this over. So minimize this. So as you can see, this is our, so we ran this as our remote debugging port. So this is our Chrome browser. You can actually hit the F12 and you can kind of see all the debugging here. You can go ahead and paste this in. And what's nice about this is, let's break this out. You should be able to go onto the sources. Notice now you see this little WASM folder here. Oop. This is the Blazor WebAssembly, yep, and this is, let's, oh, well, usually, oh, I know why. Let's stop that and run debugging. So let's retry this again. Nope. Normally, you're supposed to be able to see all of the .NET code, but it's not working. Oh, yep, that's because I got to do this. Shift-Alt-D. There we go. And that is why. So yeah, if we actually look at this, this is why. So yeah, the Shift-Alt-D is responsible for doing the kind of remote debugging. And so there we go. Now you can kind of see, if I go through here, I can actually set breakpoints. So if I go to my counter page, you can see I have a breakpoint set right here for the current account. So if I click that, you can see it says pause and debugger, and you can actually kind of view and see it. So we go ahead and say, okay, continue on. Come back here, as you can see, current count is 1 and current count is there. So you can actually kind of go ahead and debug things. And so if you actually are running this in production environment, somebody can very much do this and create a debugging environment to be able to actually see the actual Razor, HTML that you, all the Razor code that you did underneath. So that's kind of cool if you want to be able to debug some of your Razor WebAssembly applications up until the time that everybody kind of catch up to be able to support that kind of client-side debugging and looking everything up. You can end up doing it in Chrome Web and the Chrome Dev Tools. Yeah, I believe you can do this in Firefox as well. So cool. And I guess we are almost about out of time, but I'm going to open up to questions.
All right, awesome. Thank you, Brian, for a very, very cool session. I learned a few things, so now I can probably cross off Blazor from my to-do list because you showed everything that I had to look into. There are a couple of questions already.
Yeah.
Let's see if I can bring them up here. One was this one, which was about the advantages that you see to use Blazor instead of making a native application using WPF, for example.
Ooh, interesting question. Well, all right. So one of the cool things I didn't actually cover is, so Blazor was originally created with this idea that it can render to something else. So the very first implementation was to render to HTML. So they're actually working on doing things. You can actually take this and bundle up into an Electron app if you want to and release an Electron app, but you can't necessarily compile it into a native like WPF app that you can install. Cool thing about Blazor is that technically you can write a rendering engine underneath that can actually render out to WPF if you want to. And so they're actually kind of working through that, doing some, that's kind of on their blue sky roadmap of being able to say, hey, instead of rendering out to HTML and CSS, how about we render out to WPF components, or how about we render out to MAUI components, or or do some type of Xamarin components for mobile. So you can actually do all that. So I mean, it's not there yet, but it's kind of exciting because then we can kind of have one to rule them all. So definitely, the advantages, I would say, if you're making a native application, make the native application. This is great for, I'm a web developer and I want to make a, some type of PWA to be able to run in, kind of as a quick test to make sure to see, hey, maybe is there a market for creating a either native or mobile native version of my application, and I don't want to really put in a lot of work and hire all these people to iOS and Android development, WPF development. I could wrap everything in PWA and kind of launch it there and kind of have everything there. It looks kind of native-like and feel. It's not native, doesn't have all the cool native components that you necessarily have with WPF, but I mean, for the most part, it's I hate to say it, but it depends. The advantages of using Blazor is if you're a web developer, you haven't used WPF, it's great. If you're a WPF developer and you're creating a WPF application, I don't see the need to use Blazor. You have a lot of tools in your tool belt. You use the right tool for the application. So that's my response to that.
All right, cool. Then another question that came in was more about localization and stuff. How do you do translations of application? Can you use something like the resource manager that you have in ASP.NET, for example, or is this something completely different?
I haven't personally looked into the translation, but I know that's part of Blazor and what they end up having. So yeah, you can end up using a lot of the same translation frameworks that you end up using for your traditional ASP.NET core frameworks. For MVC or Razor pages, and you can end up doing a lot of that. And again, these are just kind of Razor components that you build. So as long as it's kind of built in and is compatible with ASP.NET Core, you should be able to use that inside of your Razor component. Obviously everything has a smaller asterisk. There's certain caveats here and there, but for the most part, you should be able to use what you traditionally use to be able to do that. And they're all, if you go to actually, there's this awesome link called Awesome Blazor, and let me flip back over to my browser. You can see there's a whole bunch of great introductions, tutorials, and everything like that. And I believe they do have something about translation on here. Yep, creating a multi-language translator using Azure, using Blazor and Azure Cognitive Services. So there's all kinds of cool little features in there, multi-language translation. And then obviously there's some just Blazor stuff, translation documentation, but hopefully that answers your questions.
I think it should. Another one from the same person actually is around development. Can you actually do test-driven development style using Blazor?
Yes.
It's going to be on this page of awesome Blazor resources.
Yeah, probably. There's B-Unit is a testing library for Blazor components. So that's kind of cool. You can, so if you kind of look at what Blazor components are, it's very similar to kind of Razor pages, and it was kind of built out of this idea that these web components should be testable. If you look back to the web forms days, it feels very similar to .NET Framework and ASP.NET Web Forms, but it is slightly different in the sense that it's meant to be unit testable and being able to drive via test-driven development. So kind of your standard practices of how you would create a a regular ASP.NET MVC or ASP.NET Core MVC app or ASP.NET Core Razor Pages app. You'd use those same type of methodologies that you would with Blazor. It's just a different type of tool. Instead of having everything on the browser, everything on the server being rendered, you can do some stuff on the browser, and you can end up, you don't use HTTP, you use WebSockets. So I mean, a lot of these Razor components, you can definitely create testing frameworks around them and use testing frameworks and use your unit testing. So you can definitely do test-driven development with that. So yeah, I mean, I was part of building out of the boxes. They wanted to definitely do test-driven development. So support that.
Cool. All right. Then this one, I think it's sort of a summary for a bunch of questions that passed the chat here. Is how do you do lazy loading and componentization of pages? Can you separate them in certain separate projects or assemblies and then load them on the fly, or how does it work?
Let's see. Trying to find the specific blog. Here we go. Lazy loading in WebAssembly. So if you go to the ASP.NET Core updates in .NET Preview or .NET 5 Preview 8, Daniel Roth goes ahead and talks about lazy loading components in WebAssembly. So you can definitely do that. You can go ahead and figure it out. They have this little lazy assembly loader that ends up doing this stuff, and you can kind of see they have these load up the assemblies, lazy load them via this, and then you go ahead and create everything out in your kind of routing page. So yes, you can definitely do that now. I think you can only do that with .NET 5, which .NET 5 is right around the corner. They have release candidates out. .NET 5 is supposed to be launched November 10th, if I remember correctly. So they already have, these were this is part of the features that released in preview, but I think they actually have, look in ASP.NET, and then they're up to release candidate 2. So these are basically, the release candidates are go live. They have the go live license. So if you go ahead and use release candidate now to develop, you should be able to be supported to be able to go to the actual go live and the general availability of .NET 5 when it comes out in November.
All right, cool. I'll hide this one. There was a question that I actually had, and that also came somewhat in the chat, and that is, can you use things like SQLite and stuff to store things if you're building a personal web application, for example, to keep the state of the application?
Yeah, I mean, again, it's all very similar to what you traditionally use with, your ASP.NET MVC and ASP.NET Razor Pages. Yes, you can definitely do that. I haven't actually messed with doing SQLite. Normally I do, full SQL Server or another type of SQL Server backend where I'm using, an API to kind of access that and do that kind of management state. But you can definitely use SQLite. There might be, if you look under the Blazor resources, let's see if we have anything for SQLite. Everything's just with full SQL, isn't it? Yeah. But I'm sure there's probably some SQLite tutorials out there. If not, I will actually, I'll take this on upon myself, since I don't see anything on the Awesome Blazor page. I will actually kind of investigate that and maybe post an update a little bit later on when I kind of really dive into it, because I haven't played with SQLite and Blazor, and that's an interesting proposition. So I'd love to see if that works. So
blog post there. Awesome. Then maybe one more before we wrap up, and that was performance. I think it somewhat relates to the lazy loading issue there. And that is, do you have any experience with the performance of Blazor? Not just the signal or server sites, but really performance of rendering. For example, if you want to render 10,000 lines of data in a table somewhere.
Yeah, unfortunately, most of my Blazor experience hasn't been with huge applications where I'm rendering 10,000 lines of code. There is some performance issues, and let's see, 5 performance. Trying to find, I think it's preview 7. There we go, Blazor improvements. So you can actually see one of the big things for WebAssembly was that kind of running. That's why everybody was pushing for the ahead of time compilation to be able to compile down to WASM, because again, you have that kind of layer of abstraction running a .NET runtime on top of WebAssembly. You got to do the interpreting and translation. And so for some of this, if you're doing hundreds of thousands of lines, dominant, let's say you have a list of 10,000 items in your DOM, and you're trying to go through and manipulate all that and running through with your WebAssembly, it's slow compared to something like JavaScript. They are, everybody was hoping with ahead of time compilation that would fix it up. But again, because of ahead of time compilations kind of getting kicked down the road a little bit, they're targeting .NET 6, hopefully. Again, that's not part of the Blazor. That's not the Blazor team responsibility for that. That's part of on the kind of mono team and dealing with that. So they're kind of have roadblock or waiting on them. At least that's my understanding of what I've read from the GitHub issues. But they've done in kind of compensation for the fact that they're not releasing the ahead of time compilation, they were focusing, they got the general availability done in May for the Blazor WebAssembly. Now they're really focusing on improvements and doing a lot of great little enhancements here and there. They got the core functionality up and running. Now they're wanting to be able to push it and go ahead and improve things. So they've done a lot of kind of Blazor improvements. You can see with the component rendering and the JavaScript interop and the serialization. So they've done some good improvement processes there. This was in Preview 7, so who knows as things, as .NET, 5.1 comes out or 5. Whatever comes out, that there might be additional improvements on that. But from what I've understood, it's at least a 30 to 40% increase in speed from what I've kind of understood.
That is awesome. Well, I guess there's a couple of other questions that are more detailed, I think. So feel free to hang out in the comments afterward. I guess we can wrap up here. Again, thank you for a very cool talk.
Thank you.
I learned a lot, and I hope a lot of people watching did as well. Let me quickly switch to my screen here and mention one more time that this session is recorded. Actually, the URL you are using right now to watch this talk is the one that you can use to rewatch the session afterwards in case you want to find some of the sections that we discussed. More information about Rider is available on our website. You can follow us on Twitter as well if you want. We have a blog where, incidentally, today my colleague Khalid posted a Blazor farm animal soundboard blog post. So if you want to learn about that, that is on there as well. And if you have any more questions about Blazor or just want to follow Brian on Twitter, Brian Jablonsky on Twitter there. Again, thank you for joining, and we will see you next time.
Thank you so much.